Hello and welcome to lesson 47 of Additional Maths with Mr. Barrow. This is the final lesson in the course, so give yourself an enormous pat on the back if you have watched more than half of the lessons. But if you've watched them all, I'm, in awe of your dedication to improving your mathematical knowledge. In this lesson, we're going to be looking at kinematics involving integration. In the last lesson, lesson 46, we looked at kinematics, which is the study of the position of objects, the velocity, the acceleration. And we looked at that with differentiation, how the rates of change give us the fact that velocity is the rate at which your displacement is changing. So if we differentiate displacement, we get velocity. And acceleration is the rate of change of your velocity. And so if we differentiate velocity, we get acceleration. So we're going to be looking at the reverse process today. So previously, and also in the GCSE course, you know that if you have a velocity time graph, that the area below it represents the distance traveled. So if we wanted to find the distance we travel between time A and time B, we could find that area and we would have that distance traveled. So that clearly links to integration, because integration finds us the area between a function and the x-axis and between two limits. In the previous lesson, we learned that differentiation takes us from displacement to velocity and velocity to acceleration, and therefore integration, as it's the inverse process, integration will take us the other way. If we have acceleration, we can integrate and we will have velocity. If we have velocity, we can integrate and we can get displacement. And so we're going to practice that process with some examples in this lesson. Okay, so let's say I have this example. A tennis ball is rolled down a hill with initial velocity 7 meters per second. It has varying acceleration, modeled by the equation A is equal to 6 minus 2t for the first 3 seconds of motion. So between 0 seconds and 3 seconds is the values of t that are allowed. So varying acceleration means I cannot use the Suvat equations because they are constant acceleration equations. Varying acceleration means the acceleration is changing over time. As you can see from the equation A equals 6 minus 2t, the acceleration depends on the value of t. It depends on the time. Okay, so if we wanted to know the acceleration at the start of the journey down the hill, we would substitute t as 0 in there and we would have the acceleration as 6. But 1 second later, the acceleration would be 6 minus 2 lots of 1, which would be 4. So the acceleration is changing. We want to find the velocity of the ball in terms of t. Now, the connection between acceleration and velocity is that if we differentiate velocity, we get acceleration, and therefore if we integrate acceleration, we get velocity. So therefore, for part 1, the velocity is equal to the integral of acceleration with respect to time. So we want to be integrating 6 minus 2t with respect to time, as 6 minus 2t is the acceleration. So if I integrate 6, I get 6t. If I integrate minus 2t to the power of 1, I get minus 2t to the power of 2 divided by 2, and therefore I get minus 1t squared, or just minus t squared. I also have plus c, and that's very important. Do not forget the constant of integration. It is important because there will be different velocities which would differentiate to 6 minus 2t. There might be a number on the end that I don't know, and I need to find it out. The way to find it out is by looking at the question and seeing if there is more information about the velocity at a specific time that I can then use to find the value of c. I know the initial velocity is 7 meters per second. So initial velocity means the velocity when time is 0. So I know the value of v when t is 0. So I have my equation here, v is equal to 6t minus t squared plus c, and I know that when t is 0, v is 7. So that means I can substitute those into this equation and find the value of c. So v is 7 when t is 0, so 6 zeros minus 0 squared plus c. And therefore, c is equal to 7. So my equation for the velocity in terms of the time is v is equal to 6t minus t squared plus 7. So that is the equation for velocity at any time. And I can use it to find the velocity at different points in time. Right, part 2. Find the displacement of the ball relative to the starting point when the time is 3 seconds. To find displacement, I know that differentiating displacement gives me velocity, and therefore integrating velocity will give me displacement. So, displacement is equal to the integral of v with respect to time. So I need to integrate 6t minus t squared plus 7. If I integrate that, which is what velocity is for this object, then I will get the displacement. If I integrate 6t, that will give me 6t squared divided by 2, so that's 3t squared. If I integrate minus t squared, it becomes minus t cubed divided by 3, so minus a third t cubed. And if I integrate 7, I get plus 7t. And also, I have plus some other constant. I'm going to use a different letter at this point. I'm going to use k, because I don't like having the same letter used and having a different value for that letter in the same question. Okay, so I'm going to use a constant k for the constant of integration. Now, the key here is now trying to find out what the value of k is. Have a think about what information you know about displacement. So we're talking about the displacement of the ball relative to its starting point. So at the start, how far has it been displaced? So if we take the starting point as the origin, as where we're measuring from, then at the start, its displacement is 0. It begins at the start. So I know that when t is 0, the displacement is 0. And therefore, I have 0 is equal to 3 zeros squared, which 3 lots of 0 squared, which is 0, minus a third of 0 cubed, which is 0, plus 7 zeros, which is 0, plus k. And therefore, k has to be 0. Which gives us then the displacement is equal to 3t squared minus a third t cubed plus 7t, and then nothing else. So that is the displacement. I need to now use that information to answer the question. And the question is, find the displacement of the ball from its starting point when the time is 3 seconds. So I need to find the value of s when t is 3. So all I need to do now is substitute t is 3 into this equation. So when t is 3, s will equal 3 lots of 3 squared minus a third of 3 cubed plus 7 lots of 3. And that will equal 39. So the displacement is 39 meters from the starting point. The reason I know it's meters is because we're dealing with meters per second with velocity, and so the units we're using are meters in this. So displacement will be in meters. So that is the answer to this question. So I started with the acceleration, I integrated to get the velocity, I made sure that I had the constant of integration at the end of the integral. I used the information in the question to find that constant of integration. And then in part 2, I integrated that again to find the displacement, remembering the constant of integration. I used the information that I know that it would start from the starting point, and therefore when t is 0, s is 0. and I found the constant of integration and then substituted the value of the time I wanted to get the displacement at that time. Now, just as a little hint, in some questions, the object will not start at the origin. It may be that you want to fix a position in the question, for example, relative to this post, we're going to measure the displacement, but then you throw the ball and you start 5 meters away from that post. And then at the start of that problem, when t is 0, s would be 5. Okay, so it's not always that when t is 0, s is 0. But in the majority of quick cases, it probably will be. All right. I would like you to have a go at this one. It's the final your turn. So pause once you've read it, have a go, and then we'll go through the answer. The question is as follows. A gobstopper is dropped down a hill and rolls with initial velocity 2 meters per second. Its changing acceleration is given by a is equal to 12 minus 3t, for 0 less than or equal to t less than or equal to 4 for the first 4 seconds. Find the velocity in terms of t, and secondly, find the displacement of the gobstopper relative to its starting point when the time is 4 seconds. Okay, pause, write down some maths. Okay, so the answer to this is as follows. For the first part, if you integrate 12 minus 3t, you get 12t minus 3 halves t squared plus c, which is here. Since you know that the velocity is 2 when the time is 0, because the initial velocity is 2, you can find that the c value is 2, and you get velocity is 12t minus 3 halves t squared plus 2. Then part 2, find the displacement when t is 4. The first part, you integrate 12t minus 3 halves t squared plus 2. You get 6t squared minus a half t cubed plus 2t plus some other constant, which I should have used a different letter for. Apologies. There we go, plus k. Since the displacement is measured from where the gobstopper starts, when t is 0, s is 0. So the value of k is 0. And hence, the displacement is 6t squared minus a half t cubed plus 2t. And when the time is 4 seconds, that displacement is 72 meters. If you got that right, brilliant. If you made little mistakes, that's fine. You get better with more practice. And the practice is exercise 16.3 from the textbook. And once you've practiced a few questions, you will soon find that this process gets easier and easier as you go. So go away and enjoy that, and then think about which lessons in this additional maths course you feel least confident in, that you think you need a refresher in. Watch those videos, have a go again, and then have a go at the practice exam questions at the end of the textbook. So after this exercise, there are some practice exam questions which are perfect for you to have a go at, and you don't know what questions are going to come up. You don't know that, oh, this is going to be an integration question, because the example just before it was an integration question. It'll be a question which you don't know what skill is needed, and you have to decide on that, and that is the next stage in the fluency process, is being good enough to then decide which skill is needed and then applying that skill. Okay? So I hope you've enjoyed these lessons, and I hope you are successful in your additional maths course, and I hope you take A-level maths and even further maths at A-level, because they are fantastic courses and they will set you up to be able to do whatever you want in the future. Okay, whether that be an artist, whether that be an accountant, whether that be a doctor, whether that be a writer, anything, maths and the logic and the beauty behind it will set you up for. Okay, so enjoy the rest of the course. And if you have any further questions, any comments you need to make about anything else that you would like me to cover, please feel free to comment below these videos. Okay, enjoy.